Right, so where are we? Just an intro in a minute, just to cover some things you need to think about. When your IAs are done, and on the whole, it's okay. In fact, it varies from exceptional to you're okay. You're going to survive. If your exam papers are fine, you're going to pass, and maybe you get a much better grade than you expect. I just don't know. But the IAs look safe from what I'm seeing of them. Some of them are just really, really impressive, to be honest. And so if you're worried that maybe if you struggle with your exam papers, your IA is going to affect you, it is not, okay? Now, next week, you obviously got the past papers to look at. You have to do that. You have no choice, all right? If you don't do that, that's your own decision. You're mature enough to make your own decisions. But we have one last part of astrophysics, cosmology to finish, and we have to do that when we get back. And then the SL's going to be doing the papers. I just want to talk about some things today, though, because for about 5-10 minutes, just to point out the simplicity of it, yet it can't be the real picture. Because we have this tendency, right? We've been told that there's this big bang which starts from some point of infinite energy, and that it explodes into nothing. So there's no space and no time outside it. I don't buy that, actually. I think that this thing's too weird. But they need something to work with. Now, obviously, as the universe expands, and then if you read the quantity, it's like a cake with raisins in it. The galaxies are raisins. But this is a little bit of a... the galaxies formed way after this expansion was initially taking place. So they came in later. Now, the actual model that they're using, really, is quite simple, right? You can see it in the booklet. We start here, and the universe expands outwards over time. All right. Now, there's something very bizarre about this. Is the geometry of the universe isn't clearly known. Okay. So there's no way we can find out where it started because everything is moving away from everything else. For the simple reason is Hubble's law says that anything that's at distance from us has a velocity. So everything's moving away from us. So there's no way we can actually find the centre of where it all happened, the so-called Big Bang, right? Now, the other thing that is more disconcerting about this is that with time, this universe size is believed to be somewhat linear, and they represent it by a scale factor, right? So they say, oh, it's a scale factor of 15 billion years ago, or whatever they want to say, and now it's got a different scale factor because it's bigger. So there's this inherent linearity which they assume, but I don't think that's actually true. In fact, it's known to be simplistic, and this is time. Okay, so the universe is expanding, so it means that r is a function of t. So the scale factor is changing. Now, the scale factor here would be r0, and here would be rt at some time later. So the universe has got bigger. Now, as a consequence, they try to get out what this scale factor is, and it's inherently difficult, so they go for the obvious. And the obvious one is going to be here, right? Now, we know clearly from Hubble's research and his data that we have a situation where the velocity of a receding galaxy is Hubble's constant times the distance that galaxy is away from us. And a consequence of this is that photons that are emitted by atoms in that galaxy have got longer because space-time has increased, because the universe has got bigger. It's a pretty weird idea because it's not traditional Doppler. The traditional Doppler has moving source, right? A moving source, moving observer, moving within a fixed framework of space. This isn't the case. This is space moving, and things are moving in it. So it's super weird. Now, what they're saying here is that there's going to be a wavelength change, right, over the original the observed wavelength. What's the shift defined as, actually? What's delta lambda defined as? Lambda observed minus lambda emitted. So that is the actual redshift, okay? Are you with me? Yeah? So it's changed. Is that correct? Is that correct?
Yeah. Yes, that's so.
Yeah, that's correct. So And that is deemed to be, according to them, related to the velocity of the receding galaxy over the speed of light. And the velocity of the receding galaxy is it's not massive, so this is a reasonable approximation. Now, if that's the case, what they've then done, right, because this can be simplified into 1 minus lambda e over lambda naught, right? Now, they start messing around and they call this Z